This lesson is for Mrs. Cucci's College Now Pre-Calculus class. We are on lesson 6.2, cofunction, double angle, and half angle identities. So what I need you to do is have your notebook out. You are going to be taking these notes on your own, and we're going to follow this for the rest of the year as well, so that you guys get used to taking your own notes while listening to a lecture. Okay, so by the end of this lesson, you're going to be able to use cofunction identities to derive other identities. We'll also be able to use the double angle identities to find function values of twice an angle when one function value is known for that angle. You'll be able to use the half angle identities to find function values of half an angle when one function value is known for that angle. And lastly, you'll be able to simplify trig expressions using the double angle identities and half angle identities. Okay, so what we're going to start with is cofunction identities. Okay. A cofunction identity is basically an identity that we can, set another expression equal to. In our cofunction identities, we've actually seen quite a few of these, but you do need to have these written down, get them on a note card. You should be gathering quite a pile of note cards from this unit so far. Okay, so our cofunction identities are as follows. We have sine of pi over 2 minus x, and that is equal to cosine x. We have tangent of pi over 2 minus x, and that's equal to cotangent x. We have secant of pi over 2 minus x, and that is equal to cosecant x. Okay, so you should be looking for a pattern on how you can remember these. Sine and cosine, secant and cosecant, these are our reciprocals, tangent and cotangent. So, similarly, cosine of pi over 2 minus x is equal to sine x. Cotangent of pi over 2 minus x is equal to tangent x. And cosecant of pi over 2 minus x is equal to secant x. So those are your cofunction identities. And again, please make sure you get them written down on a note card. So what we're going to do first is we're going to prove that sine of pi over 2 minus x is equal to cosine x. So you do have to know how to kind of go through and prove that these are actually functioning identities. Okay? All right, so here's my first example. We're going to prove that the identity sine of pi over 2 minus x. Oh, I'm sorry. I wrote that down incorrectly. Sine of x plus pi over 2 is equal to cosine x. Okay. So, what we're going to do to start is we are going to use for right here, okay, this is an identity, sine of u plus b, which we looked at in our last lesson, okay, our sum identity. So we're actually going to replace that with what we know that it's equal to. Now, when we do that, we want to make sure that we write this the correct way. So we do want to write sine of x plus pi over 2, and then what it's equal to. And if you have your note card out, that's what you're going to be looking at. It's going to be sine of u cosine of v, right, u and v, plus cosine of u sine of v. Okay, so essentially what we're doing is we're manipulating the left-hand side of this equation to try and make it look like the right-hand side. All right, so we're going to continue from here. Sine x is just going to stay sine x. We can't do anything with that as we speak. But we know that cosine at pi over 2, or in degrees that's 90 degrees, is 0. And we know cosine of x stays cosine of x, and sine of pi over 2 is 1. Okay, well, 0 times anything is 0. 1 times anything is itself. So what we're left with is cosine of x, which is precisely what we wanted to prove our identity was equal to. Okay. All right, so we do have 4 more cofunction identities that we also need to have recorded, so please make sure that these also get recorded. We have sine of x plus pi over 2 equals cosine x, and sine of x minus pi over 2 equals negative cosine x. And we have cosine of x plus pi over 2 equals negative sine x. And cosine of x minus pi over 2 equals sine of x. Okay, so these are cofunction identities. Okay. All right, so let's look at another example. This time, I want to find an identity for each of the following, and this is going to be 2 separate examples. Okay. So we've got tangent of x plus pi over 2. Okay, so we kind of have to start manipulating based off of our prior knowledge. What do we know about tangent? The first thing that pops into my mind when I'm thinking about tangent is that I know tangent is the ratio of sine over cosine. So what I'm going to do is I'm going to take tangent and I'm going to replace it with what I know about it. Okay, I know it's sine. We have to keep what's in our trig function over cosine. Okay. Okay, so if we look up above here, we know that we have cofunction identities that match these. Sine of x plus pi over 2 is the same as cosine x. And cosine of x plus pi over 2 is negative sine x. Okay. Cosine over sine is cotangent. And don't forget, you do have that negative, and we need to keep that. So what we're left with, pardon me, is negative cotangent x. Okay, so let's try another one of those. Let's try secant of x minus 90. All right, so secant of x minus 90, we need to start thinking about what secant means to us. And I know secant is 1 over cosine. It's reciprocal. So what I'm able to do is I'm able to take this and rewrite it as 1 over cosine of x minus 90. And if you notice, this is just written in degrees instead of like our cofunction identities up here being written in radians. And that's okay. We can do these either way. So I know from my cofunction identity above that cosine of x minus 90 is right here. Cosine of x minus 90 is equal to sine. So I can take cosine of x minus 90 and substitute in sine of x. And then my last step is realizing that I don't want to leave this written as a fraction. I'd like it in terms of a single trigonometric function. 1 over sine is cosecant. So we're going to adjust that to cosecant x. Okay. So what we've done is we have shown that secant of x minus 90 is equal to cosecant of x. Okay, so that's the identity. The identity over here, we have tangent of x plus pi over 2 is equal to negative cotangent x. So those are just separate identities that we were able to create using our cofunction identities. Okay, so the next ones that we're going to look at are our double angle identities. Oops. Okay. If we have a double angle of some measure, we'll call it x, the new angle will have to be 2x. Double angle identities give trig function values of 2x in terms of the function values of x. So basically what we wind up with are these nice little formulas that allow us to work with these double angles. So if we take a peek and make sure, again, you get these written down, I'm not doing these for you guys. My double angle, if I have sine of 2x, or 2 times the angle, this is equal to 2 sine x cosine x. Okay, and you should remember these from 11th grade from Algebra 2 trig. Okay. If we're dealing with a double angle for tangent or tangent of 2x, this is going to be 2 tangent x over 1 minus tangent squared x. And if you remember, my double angle for cosine, I actually have 3 different ones that I can use. We got cosine squared x minus sine squared x. 1 minus 2 times sine squared x. And 2 times cosine squared x minus 1. Okay, so these are your double angle identities, and we're going to work with these over the next few examples. Okay, so given that tangent theta equals negative 3/4, and theta is in quadrant 2. Find each of the following. I find sine 2 theta, cosine 2 theta, tangent 2 theta, and the quadrant in which 2 theta lies. All right, so let's start with the first one. We want to find sine of 2 theta. Now, I have to kind of go by what I'm given first. I know that tangent theta equals negative 3/4. So what I want to do is I want to try and get as much information from that as I can. So what we can do is we can actually build a triangle in order to allow us to find the rest of the information for A, B, C, and D. So if we think about tangent, I know tangent is opposite over adjacent. Okay. So what I'm going to do is I'm going to build a triangle based off of that. And since I know it's in the second quadrant, because that's given to me to make things a little bit easier. Okay, so you're going to make your right triangle. You're going to select an angle and name it theta. Tangent is opposite over adjacent, so from theta, opposite and adjacent. Now again, keeping in mind this whole time that we're dealing in quadrant 2, that's why tangent is negative. So this brings us back to that all students take calculus where everything is positive and negative. That's going to be a deciding factor for when we're doing our double angle identities. Okay, so very quickly you should be able to tell me the hypotenuse of this right triangle is 5. That's a common Pythagorean triple. Okay, so we've got our triangle 3, 4, 5. Okay, so sine 2 theta, you have to take and figure out what identity you're going to use. And since for sine we only have one available to us, we know that this is equal to 2 sine theta cosine theta. Okay, so we have to be able to determine what sine of theta is and what cosine of theta is. And since we've built this triangle, this actually becomes pretty simple. We have to make sure that when we do this, however, we keep in mind that we are in the second quadrant, so we have to use appropriate signs here. Our 2 stays. We go back to our triangle to find sine. Sine is opposite over hypotenuse, which I know is 3/5. And double checking in my quadrant, I know sine is positive, so that stays a positive 3/5. Cosine is adjacent over hypotenuse, or 4 over 5. And we know in the second quadrant, cosine is negative, so that becomes a negative 4/5. So when we go through and multiply this all together, we get 2 times 3, which is 6, times 4 is 24. We'll make that a negative. And 1 times 5 is 25. So that tells us that sine of 2 times the angle theta is negative 24 over 25. Okay, so the next one we're going to look at is cosine of 2 theta. All right, now, when we're dealing with cosine, we do have a couple of options in which identity we want to use. Any of those identities would be appropriate, depending on the information that you have. Since we have sine, cosine, and tangent, it's not going to make a difference which one you choose to use. So I'm going to use cosine squared theta plus or minus sine squared theta, just so you see how these squared ones work. Okay, so all we're going to do is we're going to take the information that we already determined and we're going to plug that information in. Cosine we know to be negative 4/5, and we do need to square it, minus 3/5 squared. When we square this fraction, negative 4/5 times negative 4/5, we get 16 25ths minus 9 25ths. And when we subtract these, we get 7 25ths. Okay, so let's take a look at C, which is going to be tangent of 2 theta. And again, we're using our identity, which we know to be 2 tangent theta over 1 minus tangent squared theta. And we were already given the information, so this is actually pretty simple to just plug in. We know that tangent is negative 3/4. So everywhere we see that tangent, we're going to substitute that in. Okay. So in the numerator, I wind up with negative 6/4. And in the denominator, I wind up with 1 minus 9/16. And we do want to keep going with that. We don't want to leave it like that. And I am going to have to come up here. I apologize. So negative 6/4. How am I going to deal with this? I need a common denominator, which is pretty simple. 1 becomes 16 over 16 minus 9 over 16. So we get 7 over 16. So now we're dealing with a complex fraction, which we know we have to take the denominator and multiply the numerator by its reciprocal. My suggestion is to reduce here before we go any further, just to make things a little bit easier on ourselves. I know 4 goes into 16 4 times, so this becomes a 1 and it becomes a 4. And this winds up giving me negative 24 over 7. All right, I have breached my 20-minute limit here. I apologize. We'll stop here and we'll do part D. In the next video is kind of a reminder as to our cofunction identities. Please make sure that you have jotted down any questions that you have on the video and come prepared tomorrow for a short quick check on 6.1c. Thanks, guys.